I'm going to show you two applications of quadratic equations. The challenge in these problems is largely interpreting the information and forming an equation. The first one's going to be a geometry type of problem that involves shapes. It's really helpful in these problems to sketch something out. So we have a rectangular sheet of plywood, 4 feet by 8 feet, and we want to add to the length and the width. This is very important. It says we want to add equally to the length and the width, and we want to double the area. So let's draw a simple sketch for this. I have a 4 by 8 piece of material. Now it says I'm going to add an amount. Let's call that x. I'm going to add the same amount in both dimensions. And when I do that, I form a new rectangle, and this new rectangle has twice the area. So let's call that N for new. Let's call this O for old. The old area is 32. The new area then is 64. So I know that area is length times width. So substituting what I know, I get 64 equals 8 plus x, width of 4 plus x. So right at this point, this is where this problem now becomes like other problems that you've done before, where we now have a quadratic equation that needs to be solved by some method. And there are different methods available. Factoring is the best method if you're able to factor it. Completing the square or the square root property, as it's called, quadratic formula, using technology. Any of these are possibilities. You should move the 64 over to the other side of the equation, and you should also expand. So let me do that now. I'm first going to expand the other side, and I'm going to write it in descending order of the exponent. So from degree 2 to 1, and then the constant. Now I'm going to gather the terms. And I have 32 subtract 64, which is negative 32. And you may want to pause at this point and see what you are able to come up with, and then rejoin me and see how my solution compares. All right. What I'm going to try to do is factor, because that is the easiest way to approach it. Now, 32 can be 8 and 4, but the product is negative, so I need one negative, one positive. That's not going to add to 12. 8 and 4 is tempting, but the signs don't work out. Let's try 16 and 2. Now, maybe I choose positive 16, negative 2. Well, that multiplies to the negative 32, but again, it won't add to 12. This looks like it may not be factorable. The only choices I have are 132, 216, and 4, 8. None of those is working. So I'm not able to do this approach. Now, you could do a check of the determinant, or the discriminant rather, b squared minus 4ac, and look to see if that's a perfect square to help you decide whether it's going to factor. So substituting the values into the discriminant and simplifying, I see that I have 144 plus 128, which is 272. This is not a perfect square. And so because it's not a perfect square, I'm not going to be able to find integer values to put into the factors. So I'm going to need to use quadratic formula. So let's do that over to the left here, as I have some space there. Quadratic formula, I would write x equals negative b plus or minus b squared minus 4ac inside of a radical over 2 times a. Let's substitute values. 12 squared, 4a. Don't forget that sign on the 32. Now I actually already simplified that radical when I was over at the right there, and I know that's plus or minus 272 and 1 in a radical. So I could try to find perfect squares here and work that through. I'm going to show you something that your calculator can do with this to get a decimal value, because while this answer is correct, it's kind of awkward to work with, and we sure don't normally use values like this in application problems in geometry. We usually use decimal values and round off. So using a graphing calculator, I'm going to run an app called Polysimult, which you probably have on your calculator. I'm just going to scroll through until I find it. And there it is. There's Polysimult and Polysimult 2. I'm going to choose this program and push enter. And what I want to do is a polynomial root finder, which is option 1. Now I have to make sure I have the right values entered in this menu. The order or the degree is 2. That's what I want. I want real and decimals. This is all looking good. Now I'll push the graph button because that links to next to do the next operations in this program. And you'll see that I have a description of a quadratic equation where a2, a1, and a0 are the coefficients. For my problem, I have 1, 12, and negative 32. So I'm going to enter those. 1, 12, and negative 32. Now I'm going to push the graph button, which in this program is solving. And there are my two roots. So let me copy these, and I'm going to import them into the program here, if I'm able to. There we are. Now, this first value here, you'll see that we get two roots, as we typically do for quadratics. I'm going to reject a negative value because we're talking about a measured length. So this is the value I'm going to keep, and what it means is that x of 2.24, or 5 rather, rounded off feet, is the amount to add to both dimensions in order to get a doubled area. Alright, here's another problem. Now that was a geometry problem. Here's a kinematics or motion problem. These are quite common. To solve these problems successfully, what works really well is to remember that speed or velocity is distance divided time, or I can write distance as velocity times time, or I can write time as distance divided by velocity depending on what I'm trying to accomplish. Alright, we have some information here. It says a boat takes 1 hour longer to go up a river. So I could form an equation saying the time to go up equals the time to go down plus 1, because the down trip is a shorter time trip. So that uses that information. Now notice I also have distance of 36 kilometers both up and down. We're going to need that. Now the fact that it's a river makes things a bit complicated. The boat v sub b is 15. The water v sub w is unknown, and that's my goal. But they play off of each other so that the velocity going up the river is different than the velocity down. The velocity up is going to be what the boat accomplishes minus what the water takes away from that velocity. When going down, you're going to have the boat's velocity, but now the water is going to contribute. So that's the key idea here. Now, I'm going to use this version of motion equations, and I'm going to say that every t is a d divided by a v. So time up then is distance up divided by the velocity up. Time down is the distance down divided by the velocity down. And now I'm going to substitute what I know about this. The distance going up is 36. The distance going down is 36. The velocity going up is 15 plus velocity water. And going down, it's 15 minus, I think I've got these backwards, hang on. 15 plus going down. I got the signs backwards. Gotta check your work as you go. Okay, so this is the equation, and you'll notice that as in the last example, I've got an equation that only has one unknown. It's in two places, but there's only one unknown. So that's what happened previously as well. I ultimately had an equation that just had one unknown, x. Once I have that, I'm able to solve. Now, this one's a bit different than the last one because it has these denominators. I'm going to want to multiply by those denominator factors to simplify the equation. When I multiply by these two factors on this fraction on the left side, the denominator will cancel, with this binomial factor here. This one will be left, and it's multiplied by 36. So I write 36 bracket 15 plus VW. On the right side, something similar happens. The binomial with the plus sign and the binomial with the plus sign, they are going to cancel each other's effects out because I'm multiplying and dividing. I'm going to be left with this binomial factor in 36. Watch your signs because these are very similar to each other. And the number 1 gets multiplied by both of those values. And if I multiply those together, it's going to be 225 minus velocity water squared. You can show more work if you feel you need to, or if that's confusing to you. All right, at this point, I have no more fractions, and I have a quadratic equation. So I'm going to gather everything to one side and reduce it as much as possible. Pause the tape now, and then rejoin me once you've done that. Okay, hopefully you've been able to work through that. I expanded and noticed a couple of common terms that canceled. I brought the quadratic term to the left side to make it positive, gathered the linear terms, and this ended up being factorable using the numbers plus 75 minus 3, leading to the roots of negative 75 and plus 3. Now, these are velocities. I'm going to reject this velocity because the water is not going to head upstream. And so this is my root, this is the solution, and I will say 3 kilometers per hour is what the water speed is. All right, a couple of common types of problems you'll be asked to work through that have quadratics.